this? N greater than 1.
Be an integer.
Uh-huh.
Consider the following two statements of an arbitrary n cross n matrix A with complex entries.
Statements. Yeah. What did you say?
दो n क्रॉस n मैट्रिक्स है A
A is
जिसका
a. Uh-huh.
जिसका एंट्रीज आर कॉम्प्लेक्स नंबर्स C के ऊपर.
Is this how we write, or do we put a square bracket? Is it correct?
हाँ ठीक है.
Right, okay. ठीक है. फिर next.
दो स्टेटमेंट दिया है कि लाइक इफ a टू द पावर k इक्वल टू I n
Oh,
आइडेंटिटी
this is not tested. Yeah, a to the power k.
इक्वल टू I n
Uh-huh.
for some integer k greater than equal to 1
For some k greater than equal to 1.
then all the eigenvalues of a are kth root of unity.
Hey, we have done this question, right?
हाँ 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 हाँ
Yeah.
ये थे पर एक सेकंड
Yeah.
वाला क्यों गलत है, समझ नहीं आ रहा.
Okay,
सेकंड
fine. That's okay. Yeah. Then
फर्स्ट वन इज ओके.
all the
All the eigenvalues of a are kth root of unity. एक्चुअली ऐसा क्वेश्चन था पर प्रॉपर ये नहीं था वो उसमें n टाइम्स n तक रहेगा या फिर वैसा कुछ क्वेश्चन.
okay, then you. What is the
And the
second statement?
second one is if for some integer k greater than equal to 1
Hmm.
all the eigenvalues of a are kth root of unity, then a to the power k equal to y. मतलब रिवर्स. a to the power k equal to identity. So कौन सा स्टेटमेंट गलत है ठीक मतलब या फिर ठीक है. We have to
Mm-hmm.
check.
Right, correct. Yeah, so one looks correct, right? I think Arnab already you said that it's correct.
It seems, but you can also tell once.
Okay, no. Okay. One is, yes, so one looks correct. Now, why it is correct? Maybe Vaishnavi, if you were there, you can tell. It doesn't matter. Just look at it as a question and just solve it. Think. Yeah, 2, I am doubtful about 2. I don't think 2 is correct. So, I've given you the answer. Maybe you can do this for homework. I'll,
हाँ अभी करते तो अच्छा
yeah,
रहेगा.
right. Yes, I mean, I also want to do it now only. It's better to do it now. So, you know this result that so the P is a polynomial applied to A, and sigma is the spectrum, which means the eigenvalues. Yeah. So we wonder what is the spectrum of P of A in terms of spectrum of A. Okay. And the result is, I said this last time, it is as simple as it gets. I don't know, is it correct? Is, is this fine? This I think I had said last time.
Yes, 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 yes.
Vaishnavi, is it okay? I don't remember if you were there that time.
No, I was not there.
Right. Okay. So P is an element in K of X. Then you can define PA.
Yeah, yeah.
Yes. So sigma PA, then you know what sigma PA is. It is the eigenvalues, collection of eigenvalues. Okay. So the collection of eigenvalues of this is equal to P times, P applied to the eigenvalues of this, of A. Okay. Right. So in our case, what should you take P to be? X to the K. So in part 1,
Yeah, it's x power k minus 1.
x power K minus 1. Well, yeah, let's take x power K. I know that will also work, but let's take x power K. Then you're just asking for the spectrum of the identity, which is just 1. Okay. And then we are saying that the spectrum of sigma A is whatever it is, whatever the eigenvalues are there, to the power K, it will be 1. which is the definition that it is a kth root of unity? Which is the definition that sigma A, everything in sigma A is a kth root?
Yeah, if the matrix were over real numbers, like then with real entries, then this one problem. With entries,
No, it will still work.
real
It will. Why will it not work? Why will it not work? It will work, right? And eigenvalues can still be complex, right? If that is no, or maybe you're saying something. You have a point there.
Okay, like it is given all the eigenvalues are. Okay, can you go?
Yeah. Part one.
Yes, yes, yes.
Part one is correct, right? Yeah. So basically, this is the thing. And again, if you don't know how to prove this, then you should prove this. Okay. You have, I mean, we have all seen this. A square ka eigenvalue is lambda square, so on, all those things. But to say it properly, like as a mathematically, this I think is the correct statement. Okay. Yeah. Prove it for over C. It is correct. At least it is always correct. This is a very, very special case. This is a very, very special case of the spectral mapping theorem in the theory of Banach algebras. Okay, that is something that one should aspire to learn. Maybe if I have time after this, I will talk about it. That's when you learn complex analysis, function analysis. Then after that you learn that's the wonderful thing. If you think about it, it's really solves a lot of issues. Okay, so this we keep it here. No need to erase it. We move to the next thing. Okay. And look, I mean, I have proved it using this, but you can just prove it. Just say that lambda is an eigenvalue of A, the lambda square is eigenvalue of A square. It's the same thing. I mean, just simple. You can do it directly. So what is the problem with the next one? I think it is false. We can just do it here. All the eigenvalues are kth root of unity, then this should happen. Any quick counter example?
You can take the matrix 0, -1, 1, 0.
Yes.
Yeah.
Right. So what are the eigenvalues of this?
It's a plus or minus 1.
Plus or minus 1?
Yes.
Because it's a reflection. Yeah.
Yeah.
Right. And no, but its square is not equal to 1. It is 1, right? No, it is not 1. It's minus 1? What?
Yes. Yes.
Good. So that's a counter example. Sorry. Okay. No, I think Vaishnavi, is this a reflection? Same. No, it is not a reflection. I mean, it's not a reflection in the traditional sense. It's not a reflection about a line. Because a reflection cannot have, to tell me, is it a reflection yeah, it is a reflection. Yeah, it is a reflection. Yeah, about the x-axis, right?
Uh,
Yeah, just put x comma y and you will know.
yes.
Yeah, it goes to minus. No, yeah, it goes to. No. We are saying wrong things, I think. It's a reflection about something. We'll just see.
रिफ्लेक्शन मतलब समझ नहीं आ रहा.
If okay, because this is a function, right, from R2 to R2.
हाँ.
Yeah, so in that way, it's a reflection or not, that question arises. Right, reflection about some line. Just yeah.
Yeah, I think so. It will be minus y equal to minus 6. It goes like, and
Okay. So yeah, maybe let's check it. Yeah, you're right. It's not a. This is what you're saying, right?
yes,
So
sir.
it is taking x comma y to. No, but it is a reflection, right, about the y-axis. Yeah.
Yes,
Okay.
yes.
Yeah, that's the point. Yeah. Oh no. Oh my God, what am I? What is happening? It is not a reflection. What is it? Tell me.
No, it is a reflection. Uh,
No. It is not a reflection. It might be a reflection, but about something else. So, what are the? I think I can guess it. Something like this, or something like this. So, it is a reflection about what? No, it is not. What is No. It cannot be a reflection, right? If it was a reflection, if it
I
was a
think so. It is it's a rotation by 90 degree.
right. Yeah. That's perfect. Yeah. This goes here. This goes here. Correct. That's the answer. That's why it's that's why the square is -1, right? Otherwise, the square will be 1. Yeah. Correct. It's a rotation by 90 degrees. Because you can write it in that cos theta sin theta form, right? Yeah. 90 degree, but you should say maybe 3 pi by 2 because it's in the
Yeah.
90
Yeah.
all that. Yeah, you know that. Good. Exactly. So that's exactly what it is. So there is a general reason why this is not true. I will not get into that right now. There is already said all this. Yeah, maybe we will. Then should we stop here? I think, right? Or is there any queries about this? So one homework that you should do is you should try to tell me what are the yeah. So here is, you should think about these things, natural questions that would come to your mind if you sit with this question for half an hour and nothing else. If you just remove everything else in the world and just stare at this question, then this kind of questions are natural, I think. What can you say about the minimal and characteristic polynomials about such a A? Okay, think about this. And again, in 2, if minimal polynomial, if I further add the condition that minimal polynomial has distinct linear, or just to say no repeated roots, if minimal polynomial has no repeated roots, no, I think the counter example already. Yeah, so the problem that is happening is so the problem you see what is happening in 2 is you like, for example, this one, right? The eigenvalues are 1 and -1, right? So the eigenvalues are 1 and -1. So they are roots of unity. Okay. They are second roots of unity. But what you have is a to the power 4 is identity. You don't have a to the power 2 is identity. Correct? At least in this example.
Yes, yes.
Okay. So that raises the question that if the minimal polynomial, if all the roots of the minimal polynomial are, if there are no repeated roots, then is a to the power t equal to I for some t. This k is given, but can you say that for some other t it will become identity?
Shubham,
Yeah.
see, if the entries were real, like the first statement is true or false, no, like we take real entries.
I mean, complex entries are also real entries, so why will it not be true?
Yeah. Okay, like if you take the identity matrix, like
Okay. A equal to identity, or
yeah.
okay, then
See, here eight. Okay, here 8 power 1 is identity, but the eigenvalues for this would be only 1.
so
It
1 is
will
a
not
kth
be.
root of unity. So what is wrong?
Yeah, it is given all the eigenvalues are kth root of unity.
All the eigenvalues are 1, which is
Okay,
kth root of unity. Yeah, that's the English. Yeah. Uh, the eigenvalues are not all the kth roots. Yeah, I understand. Yeah. So this thing you should try to prove. This is based on what the counterexample has been given. that for some thing it will become some other power, it might become identity, which is reasonable to expect, because yeah, you can understand and from this example that some other power will make it identity. Yeah, one other quick question will come, like yeah, give an example which is such that 2 prime, give an example, a counter example where just write it on your own. So you to give a counter example where no power of A becomes identity. So better counter example than what is given. I mean, better, you understand. A counter example where no power becomes identity. Okay. So you can think about that. So we'll try to understand more of this if you want later. This is module theory over integers, over PIDs, not integers. That's group theory. Okay, then we'll have to stop here, and we'll meet on Saturday 8:30 a.m. Okay, maybe I will mail you. Fine.
और मैं कब ज्वाइन करूँ? संडे?
Yes, I think